Hi class, let's take a look at problem 15. Now, they're going to want us to find inverse functions of these three problems. And you do have to take a look at what the possible inverse is going to be. The only one that's going to give us a problem is going to be problem B, because its inverse is not going to be 1-to-1. Now, let me show you the graph of problem A. Problem A is just a linear function. So I'm just displaying this. So the inverse of a linear function, it's going to be technically also 1-to-1 since it passes the horizontal line test. So in this case, they're not asking us to show that it is 1-to-1. All they want us to find is the inverse. And let me just put a comment that f of x is 1-to-1. In this way, we don't have to worry about obtaining possible inverses. Now, on all of these, you're going to start by letting y equal to the values of f of x. And what this is going to do is it's going to actually take us back to the original substitution of y is equal to x plus 8. And then the next step, it's actually to replace x by y, and technically y by x. And let me just rewrite it. In this case, we're going to end up with x is equal to y plus 8. And then our last step is going to actually be to solve for the y's. So subtract 8. As I stated before, since the function is linear, we're not going to have a problem. So in this case, y is equal to x minus 8. Let me write my final answer as f inverse of x is equal to x minus 8. And in this case, since the function is linear, we don't have to worry about restraining the domain. We're good to go on that one. Let's take a look at problem B. Now, problem B, it's a fourth root. And the inverse of a fourth root, it's an x to the fourth power. And as I mentioned before, this is going to give us a problem. Now, let's take a look at the actual graphs of these two. And you notice that technically the x to the fourth, it's 1-to-1. It passes the horizontal line test. But there's going to be a minor problem when we find the inverse, because this one is not 1-to-1. And it basically fails the horizontal line test. So in order to make it 1-to-1, we're going to have to restrain the domain. Now, let me go back to redoing all the steps just like we did on the previous problem. So at the moment, f of x is in fact 1-to-1, but the inverse is not going to be. So let me just write that f of x is 1-to-1. So technically it'll have an inverse, but as you technically let y equal to f of x, well, on the good news, this is going to take one step. You're going to have y is equal to x to the 1/4. And then at this point, we replace x by y and y by x. And let me rewrite it. So in this case, we're going to end up with x is equal to y to the 1/4. Now, as we find the inverse, we're going to raise it to the 4th power. And then you're just going to end up with x to the 4th is equal to y. And we would say that in this case, y is equal to x to the 4th. But let me just put a disclaimer here. And in this case, not 1 to 1. Now, in order to make it 1 to 1, we're gonna have to pick a portion of the graph, and this is gonna cut the graph on technically 2 pieces. And here's the basic idea. As we look at x to the 1/4, well, this is the function and it contains 1, 1. As you invert it and technically find the inverse, we end up with a function that is not 1 to 1. And technically you're using all of these coordinates and replace the x on the y's. Now, an easy way to spot which piece is going to be the one that we need, technically, it's going to start at 0, 0. So that means that the split is going to start at 0, 0. And that's going to make either this piece or this piece. Now, if 1, 1 is part of the original function, as you invert every coordinate, well, x becomes y, y becomes x. It also has to be on the inverse. So that means that this is technically 1, 1. This piece we don't need. So technically this whole piece will be eliminated, and we're only going to be using from x greater than or equal to 0. So as we write your final answer, I'm just going to rewrite it as f of x, or actually f inverse of x, is equal to x to the 4th for x is greater than or equal to 0. This one has to have a disclaimer since technically the entire function, well, happens to be not 1 to 1. Okay, that's actually it for problem B. Let's move on to C. And good news on C, not a major problem. It's an x to the 3rd. So let's take a look at what that function looks like. And it is 1 to 1. As we find the inverse, you're going to end up with a cube root. The cube root will also be 1 to 1. So we're not going to have that problem that we had on the other one, on the x to the 4th, that it results in not being 1 to 1. And let me just put a comment. In this case, f of x is 1 to 1. And I'm just going to let y equal to f of x. And then we have y is equal to 2x to the 3rd minus 5. Do the replacement. I'm just going to write it as replace y technically by x. And what this does is we're now rewriting it as x is equal to 2y to the 3rd minus 5, and then we'll solve for y. Okay, so let me add the 5 and add the 5. So this is going to give us x plus 5 is equal to 2y to the 3rd. And then we'll divide it by 2, divided by 2. So we end up with x plus 5 divided by 2 is equal to y. We have actually a y to the 3rd. And then at this point, we'll cancel the y to the 3rd by taking the cube root. The cube root is also 1 to 1, so we don't have a problem here. We can just rewrite it as y is equal to a cube root of x plus 5 divided by 2, and then the inverse function happens to be the cube root of x plus 5 divided by 2. Once again, cube roots happen to also be 1 to 1, so no need to restrain the domain. That's actually it for problem C.